Hello, everybody. Welcome to the presentation of the paper Extended Reality for Teleoperated Mobile Robots, with authors Edivaldo Santos, Arturo Batistuto, Karan Takedini, Pedro Lazari, Kellen Vivaldini, and Lídia Rocha. The agenda for this presentation is basically introduction, methodology, results, and finally, conclusion and future work. Brief introduction starts with problem definition. In smart factories of the future, robot teleoperation can be challenging and therefore impose high requirements on user training and expertise. Secondly, how to achieve higher teleoperations efficiency and safety for use cases like the remote control of robots inside factories and control of heavy machinery in risk environments such as mining. So this paper addresses human-robot interaction scenarios in which extended reality technology is used to improve mobile robot teleoperations by increasing user friendliness and minimize requirements on user training and operators' previous expertise. So let's describe the methodology, starting with the technical assets adopted in this study. First, Magic Leap 1, a mixed reality headset that contains features suitable for the experiment, like it's a standalone device that does not require a connection to PC. Secondly, Oculus Rift S, a virtual reality headset with good graphic quality, very good for this experiment. Thirdly, UltraLeap Leap Motion, a computer hardware sensor device that supports hand motions as input, designed to provide hand tracking in virtual reality while the device is mounted on VR headsets such as the Oculus Rift S. Then we have the robot TurtBot 2i, a research mobile robot with a modular chassis equipped with cameras and sensors and host-compatible netbook. Sensors and cameras, the main component of the TurtBot 2i for this experiment is the depth sensing camera, the model Kinect, to assist the remote control task. Then we will have HOS, the Robot Operation System, a flexible framework for robot software coding. And finally, Unity 3D, a cross-platform gaming tool developed by Unity Technologies that has been extended to support desktop, mobile, and XR platforms. About the architecture, the proposed end-to-end human-robot interaction network architecture includes the robot component at one side, and from human side, it includes the mixed reality and virtual reality headsets component. Regarding the functional architecture, the integration of HOS and Unity 3D is enabled via HOS bridge through a WebSocket connection. It can therefore subscribe to messages in one HOS part and publish them in the other HOS part. Okay, regarding the experiment procedure, to evaluate the robot teleoperation efficiency, we defined an experimental procedure as follows. The ability of two XR users to execute certain tasks remotely based on extended reality technologies such as mixed reality and virtual reality, compared to one user based on a traditional physical controller, namely here baseline. So we measure remote robot control using this traditional physical controller, namely baseline here, compared with virtual reality robot control based on joysticks mode using Quest 2 headset and mixed reality based on right and left hand gestures mode using Magic Leap headset. The robot view was available to testers exclusively via the video transmitted by the robot camera to available displays, the notebook for the baseline, and the headsets for the mixed reality and virtual reality modes. A very important note, measurements were limited to 3 participants due to interaction restrictions derived from COVID pandemic. Okay, about the task. The task consisted of teleoperating a robot from a control room so that it passes through a door, turns left 5 meters ahead, goes through a slightly curved path 1 meter width and 15 meters long until the parking slot. It is the end destination. And finally, regarding the measurements, we established 4 measurements to characterize the quality of service and quality of experience. The first one, operational errors. The number of times the robot hits obstacles. A note, one of the major open problems in human-robot interaction relates to human safety during collaborative work with robots, for example, in manufacturing environments. Okay, the second measurement was the completion time. That means the total time to complete the path taken by the robot. The third measurement was effectiveness, measured by how effective an XR user controls the robot along a predefined path. It is based on average completion time and number of crashes. And finally, perceptions of task difficulty to capture subjective participant response while operating the robot. Okay, let's go to the results, but before, one initial clarification. The 3 testers involved in these measurements had different levels of previous XR experience and familiarity. Thus, the average result of each control mode represents a good balance between users with low and high experience. So, the highlights of the results. Firstly, virtual joysticks gave users the advantage of clear notion of users' movement effects on the remote robot. In short, virtual reality control mode has had faster completion times and smaller number of crashes. Secondly, handling 4 keys in the physical computer keyboard control mode, right, left, move forward, and stop, has led to user confusion, especially in stressing situations. Consequently, it has fueled the highest number of operational errors and crashes. In real scenarios, this implies serious safety issues and efficiency downgrades. And finally, human-robot interaction efficiency during the path motion was best with mixed reality and virtual reality applications, as shown in the graphics, thanks to the integrated visualization of robot camera view and virtual control commands at the same advanced user view in the headsets. Last part of this presentation is conclusion and future work. In summary, this work concludes initially that the combination of robotics and XR technologies provides significant advantages over traditional robot controlling technologies. It respected to teleoperations user-friendliness, efficiency, and effectiveness. And as a consequence, human safety on the collaborative work with robots. Regarding future work, we have some proposals. First, enhance current experimental procedures with engagement of higher number of participants. So to observe if additional conclusions surface especially those of subjective nature like user-friendliness perception. Secondly, build a functional dump in simulated type of environment, so to allow wide availability for others to repeat and add additional value to this experiment. And finally, profit from the evolution of mobile broadband technologies, more specifically the worldwide rollout of 5G networks, to enhance scope to compare the effects of wireless system communication like Wi-Fi, 4G, and 5G on the remote controlled robots. That's it. Thanks for your attention. Bye.